Question 5. Why are we losing elimination as we move down this chart? Now, with ethoxide, as long as we're not dealing with that tertiary carbon, we have the possibility of SN2 and E2. So that's where these are coming from. This is not a question of different mechanisms the way that the previous one was. We're going to have E2 all the way down because we've got a strong base and we're not worried about the alkyl halide carbon. This is more likely SN1, as we talked about in the previous question. So, in that case, the only thing my strong reagents can do is E2. It blows everything out, 93% of it. Substitution is simpler. It involves less entropy to be overcome. Alignment has to happen for the E2 reaction to work. The SN2 reaction doesn't require the alignment of adjacent atoms. It just requires the approach of the nucleophile on the same basic line as the leaving group. But it's still sensitive to sterics. So if we take that second case, well, the attack is more direct, but still not easy. There's still two methyl groups in the way. So we're starting to see SN2 for the first time here, but it's not dominating yet because the E2 reaction is still simpler despite entropy than the approach is to the leaving group carbon. When we get to the last case where it's primary, completely opposite picture to where we started. That's the easiest, most approachable, other than just a methyl group there, is a primary group. So we're looking at SN2 just absolutely taking over. But alkoxides are still relatively strong bases. So we're still going to see some amount of elimination just because there's enough power there to do it. And we have 3 different equivalent hydrogens that would give us the same product. So the alignment problem is less here because we have more hydrogens to go anti to the bromine as rotation occurs. But it's not a great alkene energetically. The strong base is still going to do a small amount of it. So at first, that's all we can do is E2. At the end, you're looking at sort of residual E2 that's just because it's there and it's possible. Not that it's really all that different. Not that it's really that favorable. It's not a great alkene. In the middle case is where things are problematic because substitution at secondary carbons is very useful. Clearly, it's not as simple sometimes as we'd like for it to be. This is a bad example because normally your nucleophile is not also a strong base. There are ways to get around that where we could actually do that substitution in the center a lot more cleanly, avoiding most of the elimination. But the secondary carbon does present issues for us. It is capable of both, it's basically capable in almost equal measure of all the possible mechanisms. We can do SN1 reactions on it. We can do SN2 reactions on it. We can certainly do E2. And if nothing else is there to do, then there's always E1. So the secondary carbon presents some unique challenges, especially if your nucleophile also happens to be strongly basic like this. So if I wanted to do this directly to make that ether, I'd really have to consider what my conditions are. And I'd have to work at driving this a little bit better. Because this is obviously not great. You know, if you wanted substitution here, you're looking at less than half. And, you know, I say this a lot, but you should really look at the yield of the product you're interested in as like an exam score. That ain't it. By the time we get to the bottom, all right, we're in the right range now, 90% or so. Not perfect, but at least we're pretty confident we're doing everything right. If we're getting numbers in the 90s, it's unlikely you're screwing up massively. There's still room for improvement. You're not at 100, just like an exam score. But when we're looking at something where you're not even in a plurality, not even half of the product is what you might have wanted, then you really have to think about doing this differently. And there are ways to do it that would be a lot better than that. So it's not a dead end. It looks that way in this question, because I didn't want you to write me an essay on reactions you don't understand yet. But it is not a dead end. It is, however, a little bit more technically challenging than either the top case or the bottom cases.